end of class, okay, last time we filled out the Venn diagram, right? We filled out this Venn diagram based on 26 total who were here. We went through, some questions and then filled out the Venn diagram. Well, today we are doing the same, okay? We are looking at interpreting Venn diagrams as well as two-way tables, okay? So a lot more is happening today. A company is performing a market test on 2 different lacrosse sticks, okay? Out of 150 people. So that Venn diagram has to equal what? 150, right? Okay. 60 people liked, is that just sticks? Is you guys who play lacrosse, is that what it means? Or STX? I don't know. Okay. And 95 like Maverick. 25 like both. Determine the following. Okay. So, what do we know? What are some of the things we know so far? The total is 150. So we know that this whole Venn diagram has to equal 150. Okay? What are the 2 events per se? What are the 2 types of sticks that we have? Lacrosse sticks. Yep. Me break, yeah. Okay. What else do we know? What's one thing that we could take care of right now? Kate? And where would that go? Good. 25 would like both. Okay, so we know that. We're taking care of the both. One thing with Venn diagrams, you want to work inside out. Okay? So, we know 25 like both. Now, we know 60 should be this circle, right? So what is only 6? What is only 6? David, how'd you get it? Okay. So to find only, okay, you take the total, which was 60, minus the middle. Okay? Now, how about the other one? What do we have? Campbell? 70. So we do the same thing. To find this, 95 minus 25 gives us 70. Now, if we add those 3 numbers up, what do we get? 130, but what do we need? 150. So we have a 20 that is what? Doesn't like any, right? So 20 would go on the outside. So to find 20, you take the total minus all 3 of those numbers. So 35, 25, and 70. Okay? Does that make sense? We did this in the last activity. So now, what is the probability a person likes 6 or the Maverick or Maverick? What would it be? How would we figure this out? Saying or. So what are we doing? Adding. Adding what? Yeah, Riley. Okay, anything else? Eleanor? Add the 25. So where it says or, okay, and it's asking for probability, you are adding 35 plus 25 plus 70 because it's either this first one or the second one. So you're adding all 3 of those together. Now, since it's probability, this would be over the total. Okay, so we have 130 over 150. 13 over 15. Okay, what is the probability that a person does not like either lacrosse stick? Yeah. 20 out of 150, 2 out of 15. Good. Yep, go ahead. How would I answer the next one? Charlie? Perfect. So we're adding who does not like. So we have 70 plus 20 over 150. So 90 over 150. What does that reduce to? Okay. 3 over 5. Good. All right. What is the probability that a person does not like the Maverick stick? Yeah. 20. It's the outside that doesn't like this one. So you're eliminating the whole circle. Okay? So what is the probability that a person does not like the Maverick stick? Yeah, Kaden. How'd you get it? Good. 55 over 150. 11 out of 30. Awesome. Okay. Now, if I wanted to know, just in general, how many people only like the Maverick stick, what would it be? What would the number be? 70 over 150 if I was asking for probability. But if I'm just looking at the number of people, it would just be 70. Okay, see the difference there in terms of terminology. All right, let's do another one. Here we're in percentages. So since we are in percentages, this whole Venn diagram has to equal what? 100. So the whole Venn diagram has to equal 100%. Okay? The probability that a Ludlow student has been to Florida is 44%. The probability that a student has been to Vermont is 60%. The probability that a student has been to either Florida or Vermont. So this is different. Okay? This is different. This actually brings us to a formula to know of. Okay? So anytime you have to use or find the or, okay, if you're looking for probability of event A or event B, okay, you would then do, and this is on the previous page, we'll get to that in 1 second, probability of A plus probability of B minus probability of A, oops, and B. Okay, this actual formula is on the previous page, which we'll go back to in 1 second. Okay, so to find the probability of A or B, this is a formula you could use, which guess what, guys? We've been doing this already. Okay, probability of A plus probability of B minus the probability of both. Okay, so what that looks like, what do we know based off of this? What do we know? Okay, we know the probability of Florida is 44%. So we know eventually this whole circle is going to equal 44. Okay, we also know probability of Vermont is 60. Okay, so we know this whole circle is going to be 60. Okay. We also know probability of Florida or Vermont is 83. So what do we need to find? What do we need to find? Eleanor? We're the and, so we don't know where that middle is. We don't know that middle. Okay? We don't know that middle. So we, in this particular case, we are going to use a formula that I just gave you, okay, by setting it up. We know 83 equals 44 plus 60 minus, let's say, the x, because the x represents both. So how do I figure that out? What do we do? Yeah, Grant. Solve for x. All right. So go ahead and solve for x and tell me what you get. How many people have been to both Florida and Vermont? 1 second. You have a question or the answer? Okay. All right. Keaton, how many have been to both? 21% have been to both. Okay. How many just Florida then? How do we find just Florida? Come on, you guys. Pearson. And what do we get? 23. Good. How many only Vermont? Keaton? 39. Now, when I add this up, should I get 83? Well, when I add these guys together, right, we already know what the OR is. So should I get 83? Yeah. However, we don't know what's left over. Who has not been to Florida or Vermont? How many? What's the percentage? Yeah. 17%. Good. Okay. So, what percent of students have been to both Florida and Vermont? We found that already, which is 21%. What percent of students have been to neither, which is 17. And then what percent of students have only been to Florida? Yeah, 23%. Now, this is just one way of solving this. A lot of you guys can figure out different ways, okay, to solve this. Now, we're going to kind of backtrack to see where this formula is used. So if you go to where it says SAT application, which is on the previous page at the top, okay, this formula could be used, or you could use the Venn diagram. Either one, okay? Either one. Some people just feel like the Venn diagram takes a little bit longer, so they use the formula right away, okay? So out of all the seniors in the senior class, 35% are on the honor roll, okay? 45 are athletes. 22 of the seniors are students who are on the honor roll and are athletes. Okay, how many seniors are on the honor roll or are athletes? So if we were to use the formula, probability of seniors or athletes would be probability of seniors plus probability of athletes minus probability of seniors and athletes. So you wouldn't be subtracting anything, you would just be using the formula, okay? Which means 35% are seniors plus 45% are athletes. Then if we minus the 22 who are both, we will be able to find out the probability who are seniors or athletes. So what do we end up getting? What's the percentage probability of selecting a senior who is on the honor roll or is an athlete? Riley? It would be 50%. Good. Okay. Try number 2 and 3. 3 we actually saw already. So 2 and 3. Okay. For number 2, how many of you did get 45%? Good. Okay. Number 3. We have to find the and, okay? How many students that are randomly selected are both varsity athletes and on the honor roll? So, how many seniors are varsity athletes and on the honor roll? What did we get? Yeah, Grant. 12. How many of you did get 12? Okay. So, out of 200 students in the senior class, 13 are either varsity athletes or honor roll. So that's 113. So we know varsity athletes plus honor roll minus varsity athletes and honor roll. So there are 74 seniors who are varsity athletes, 51 who are on the honor roll, and we don't know both. Okay, so this is how it's set up, okay, in order to find 12. Determine the probability of randomly selecting a senior who is a varsity athlete and on the honor roll. So now it's asking for probability. What would that look like? Yeah. Perfect. Perfect. Okay, so there is where the formula comes into play. Do you have to use it all the time? Absolutely not. If you want to use the Venn diagram, you can. Okay, so any questions? Let's go back to where we were. All right. How many of you have seen some sort of table like this? Okay. These are all over the SATs. Okay. All of this probability situations, doesn't matter. They're always giving you some sort of two-way table. Okay. So one thing with this, right? Some of the shortcuts to remember, or you're adding together and you're looking for the intersection of the events where they're both occurring. Given is where the denominator changes in terms of you're looking to see with that notation what came next. We'll get to that in 1 second. So first and foremost, anytime you're given a table, most important, you want to make sure you know all the totals. So right now, I want you to find the totals of male, female, and the total numbers of students surveyed or people surveyed. All right. How many males were surveyed? James. 77. Good. Jaden, how many females? 73. And then in total, Eliza, how many? 150. So 150 is the number of people surveyed. Okay, 150 were the number of people surveyed. Okay. So, what is the probability that a person surveyed favored watching football on TV? What would it be? We could reduce after. What is your fraction? Yeah, Kip. Good. 52 out of 150, which would reduce to what? Okay. Good. Good. All right. What is the probability that a person surveyed favored watching basketball or baseball on TV? Basketball or baseball? Yeah, Eleanor. How'd you get it? Good. 98 out of 150. Because remember, all of basketball, 38 plus 60 gives you the 98 out of 150, which is 49 out of 75. Okay. What is the probability that a person surveyed was a male? Eliza. Good. 77 out of 150. What is the probability that a person surveyed is a male and favors basketball? Here you're looking for what they have in common. It's already done for you. Okay. Male and basketball. Yep. Good. So it was 22 out of 150. 11 over 75. So you're looking where they both have in common, males and basketball is 22. Excuse me. All right, so here's where the given comes in. Okay? Given the person is female. So where you see this, this is your denominator. So how many females are there? 73. Out of 73 females, how many of them favor football? Eliza? 12. Okay, so here it shortens the pool. Okay, because you're only looking at females. Now for G, given the person favors football. So how many people like football? 52. Out of 52, how many of them are females? 12. And then what does that reduce to? Good. Okay. What is the probability a person surveyed is female and favors baseball? Riley? Excellent. 45 out of 150, which is 3. Okay. So now I want you to find which probability is greater. Okay. You have the probability male given that they like baseball. So keep in mind, okay, whatever second here is your denominator. Okay. Whatever second is your denominator in that notation. So, probability, male selected, given that they like baseball. So, baseball, how many people like baseball? 60. Out of those 60, how many of them are male? 15 out of 60, which reduces to 1/4. Good. Okay. So then we have the probability of female, given they like football. So how many people like football? 52. How many of them are female? Okay. Just 3 out of 13. Okay. Which probability is greater? Good. Male and baseball. Okay. Great. So you guys are going to try the next one. Okay. You're going to try the next one in terms of dominant hand. Okay. You're going to try all of number 2. Okay. All of number 2. Go ahead. So anyway, all right. So as we go through this, all right, just go ahead and correct your answers. You see it. All right. So how many two-year-olds were surveyed? There were 20. Okay, there were 20 surveyed. How many people surveyed are right hand dominant, which were 16. Okay, so both of those are correct. Then it says, what is the probability that a person is left hand dominant? It's 24 out of 40, which would reduce to 3/5. Good. What is the probability that a student surveyed is 18? We have 1/2. Good. Then for E, this is where you have to use the formula. Why? Did someone get something different? Riley? 25 out of 40, right? Okay, that is correct, because how many two-year-olds are there? 20 out of 40. How many righties are there? 16. Now, looking at that chart, is there two-year-old righties? How many? 11. So we have to subtract that, okay? Because it's double counted again, okay? So here's where anytime you see or in the two-way table, you have to subtract if there's any sort of overlap, okay? Where they're both occurring, the intersection, you have to subtract, okay? Does that make sense? Okay? It takes a little getting used to in terms of the terminology, but when you see or, you have to make sure you're subtracting that overlap, okay? Now, we haven't seen a problem like this, so if you had it incorrect, that's fine, okay? That's okay, all right? So from here, you end up with 25 out of 40, which is 5/8, okay? Then, what is the probability that a person is an 18-year-old and is a lefty? Good, 3/8. Okay, you're looking for the intersection. 18 and lefty. Okay, so and is looking at where they both have in common. Then the last one, what is the probability that given the person is an 18-year-old, which is out of 20, okay, out of 20, how many of them are lefty? 15 out of 20, and then you reduce, okay? So if you notice, either if we're doing this as a Venn diagram or a two-way table, the wording is most important, okay, what you're looking for. You guys will know how to fill out a two-way table. You will know how to evaluate a two-way table, okay, and a Venn diagram, all right? So I want you to finish off with 3 and 4, okay? Then we're going to look at one of the practice problems that I have for you. So 3 and 4, I want you to do right now. For 3A, what did we get? Quickly, Jaden. 118, you mean? Yeah. 55 over 118. Good. For B, what do we got? Anybody? Kip. Good. 55 over 221. And C. Anybody? Pearson, thank you. 63 over 78, and if you could reduce, you can. I'm not sure if you can. But number 4, what do we got? Which is the reasonable conclusion? Anybody? Catherine, thank you. D is correct. Okay, D is correct. So if you, for practice, okay, in your yellow, some of you had, or all of you had yellow in this class, 3.2 practice, which is on like page 4. It's not labeled, but page 4, 1 through 6, and then 9. Okay, so it's a little bit of what we did. Now, some of you guys had questions. If you look at the part of your notes where it says shortcuts, okay, it says anytime you see or, you add together all the cells that include one event or the other event. Make sure not to count the overlap. So that's why we subtract, okay? And find the intersection of the row and column of the events you are looking for. So where they're both happening. In given, determine the given event and make this your new total denominator. All right?